All right, so let's answer this question here. It says Jane has 3 bags of lollies. Lucky Jane. In bag 1, there are 3 mints and 3 toffees. In bag 2, there are 3 mints and 2 toffees. And in bag 3, there are 2 mints and 1 toffee. Jane selects a bag at random and then randomly selects a lolly at random. Find the probability that she chooses a mint from bag 1. Okay, so let's begin by figuring out what is the best way to represent this. And it really just comes with practice, but you should know that the best way to represent this is through a tree diagram. So that means we're going to go, all right, I can either get bag 1, bag 2, or bag 3. And I'm selecting this randomly. So that means there is a 1 in 3 chance that I could get this, there's a 1 in 3 chance I could get this, and there's a 1 in 3 chance I could get that. Then from there, you want to figure out the probability that she chooses a mint from bag 1. So instead of drawing this whole thing out, because there might be parts that are irrelevant to us, let me just draw what's necessary. And then as we go through the question, I'll just add in the parts that I need. So here it's asking us to choose a mint from bag 1. Well, in bag 1, there are 3 mints and 3 toffees. So that means if I was to choose a mint from bag 1, well, there are 6 things to choose from. And how many of those are mints? 3 are mints. So that means if I want to find, and I'll grab another color here, if I want to find the probability that she chooses a mint from bag 1, that is just saying we are going to get a mint intersection of 1. Notice that there is no language here of like given or any conditional type language. This is simply 1/3 times, now 3 on 6 is the same thing as 1/2. So that means my answer is going to be 1 on 6, and that's it. So make sure you read the question carefully. Don't think it's saying something conditional when it's not. You just got to be careful. Next it says, find the probability that she chooses a mint. So this isn't necessarily saying that she's choosing it from bag 1, 2, or 3, but just a mint in general. So that means what we need to find is what's the probability of her pulling out a mint from any one of the bags? Well, the probability of her pulling out a mint from bag 2, well, there are 3 mints and 2 toffees in bag 2. So that means that there is a 3 in 5 chance because 3 plus 2 is 5. So there are 5 things in total and 3 of those things are mints. If we want to find the probability of her pulling a mint from bag 3, well, there are 2 mints and 1 toffee. So there are 3 things in bag 3, and 2 of those things are mints. So that's going to be 2/3. So therefore, if I want to figure out this one, if I want to figure out the probability of mint intersection of bag 2, it's going to be 1/3 times 3 on 5. And that's going to be, now this is where you should always cancel, because this will cancel with that, leaving me with 1 on 5. And if I want to figure out this one, this would be the probability of mint intersection of bag 3. This would be 1/3 times 2/3, which is going to be 2 on 9. Now, if I want to find the probability that she chooses a mint, what that is the probability of m intersection of 1 plus the probability of m intersection of 2 plus the probability of m intersection of 3. That is going to give me the probability of getting a mint. So that's going to be 1 on 6 plus 1 on 5 plus 2 on 9. Now, we've got a calculator here, so let us use this calculator. So I'm going to go control divide 1 on 6 plus control divide 1 on 5. Oh, that's not a 5, sorry. I'm trying to do this by touching the screen. It's not that good. 2 on 9. All right, that looks good. My answer will be 53 on 90. So we'll come here and we'll go 53 on 90. And we're going to now highlight that answer. Let's highlight away. Highlight. Perfect. Now we come down and we say, what's the probability that she chose bag 1 given that she gets a mint? Immediately, alarm bells start going off when you see words like given. You know this is going to be a conditional probability question. So the probability that she chooses bag 1 given that we've got a mint. So that means we want to figure out the probability of 1 intersection of m over the probability of m. Well, we just figured out the probability of m. The probability of m is 53 on 90. And we've also figured out the probability of 1 intersection of m. That's 1 on 6. So that means we just come up here now and we're going to go control divide 1 on 6 divided by, and you could even just take this straight out, put it there, hit enter, and we're going to get that answer right there. So that means what we're going to get here is, drum roll, 15 on 53. That's going to be our answer. So hopefully that makes sense on how to get those answers, and I'll see you later.